So, dear students, welcome back to our discussion on refrigeration and air conditioning. So, in the third module, there is a small portion called Vapor Absorption Refrigeration System. Okay, so in the second module, we were learning about the vapor compression refrigeration system. That is, by running a main compressor, we were compressing the refrigerant to a high temperature, high pressure, where this refrigerant after this compression process will be rejecting the heat at the condenser, and after passing through a expansion valve, it was later admitted to the evaporator. So, from experience, we know that the compressor is the largest energy consuming or specifically electricity consuming device in this VCRS system or the vapor compression refrigeration system. So, is there any way out? Is there any way to avoid the working of this compressor and at the same time producing the same refrigeration effect? And that is where this VARS or vapor absorption refrigeration system comes into picture. VARS is the short form for vapor absorption refrigeration system. So here what is happening here is instead, that is the compressor, the entire compressor work is replaced by three steps. One step is called absorber, the second step is done by the solution pump, and third step is done by the generator. So let us see how this absorber, solution pump and generator is bringing out the necessary process required for refrigeration system. So we can start from the evaporator where the required refrigeration effect is produced. Okay, so evaporator is our common freezer compartment, just like we studied in our module 2. The evaporator compartment of a similar to the evaporator compartment of a vapor compression refrigeration system. So, so here let us take the example of a ammonia as the refrigerant. So, ammonia refrigerant, after flowing through this evaporator, it will be taking the necessary heat or it will be extracting heat from that evaporator or the freezer compartment and getting vaporized. So, this low pressure ammonia vapor, after absorbing heat from this freezer compartment or the evaporator, it will be admitted to the absorber. So what is happening in the absorber is this low pressure ammonia is getting dissolved or it is getting absorbed by a water medium. Okay, so we have learned in our junior classes that water or H2O is having a very high affinity, or it has a very high absorbing capability to absorb this ammonia substance. Okay, so due to this chemical affinity of water towards ammonia, when we are passing this low pressure ammonia vapor over the water surface kept inside this absorber, this water will be readily absorbing the ammonia vapor. Okay, so this ammonia vapor will be getting absorbed by water. So what will happen to this ammonia vapor? It is actually getting dissolved, or it is getting absorbed by the water medium. So what is happening to the energy content of this vapor, ammonia vapor? That latent heat of condensation will be released to the water medium, and this will be cooled by this circulating cooling water circuit. Okay, so now what is happening to the water available in this absorber? Now it is fully rich or fully absorbed with this ammonia vapor, or this ammonia vapor has actually condensed to get dissolved inside this water. So this water now, which is fully or which is rich in ammonia, it will be pumped to a higher elevation or to another reservoir called generator by means of this solution pump. So actually this is where this solution pump is coming in picture, how it is avoiding the work of a energy consuming compressor. So okay, so here instead of a compressor, so here instead of a dedicated compressor, just like we discussed in the module 2, we are not using any compressor for increasing the pressure of the refrigerant, but here we are using a simple hydraulic pump or a solution pump, where this pump will be pumping the water medium which is fully or rich, which is rich in ammonia refrigerant, and this solution pump will be pumping or pressurizing that water containing ammonia towards this generator. Okay, so earlier we discussed that water medium is having a very high chemical affinity to absorb ammonia. That is what exactly happened in this absorber. But how this reversal is possible? Is there any method to retake or desorb this ammonia from this water? Yes, by supplying any heat energy. Okay, so by means of any steam or electrical energy, we can apply heat energy and heat this water containing or water which is rich in ammonia. So, okay, so suppose we are heating it above the boiling point of ammonia and water. So compared to water, the boiling point of ammonia is lesser. So when we are heating this rich solution of water containing ammonia, first of all, the ammonia vapor will be the first one to come out rather than the vapor form of water. Okay, so the vapor form of ammonia which is coming out due to this heating of this water containing ammonia. Okay, so whatever ammonia vapor is getting produced, and that will be at a very high pressure also due to this heat energy supplied at this generator. Okay, so this generator is actually generating ammonia, or it is actually separating ammonia from this rich solution of water. Okay, actually this generator is generating ammonia which was earlier dissolved in water. Okay, so whatever water is getting separated or remaining here, it will be again admitted to this absorber by means of a reducing valve. Why we are using a reducing valve like this? Because due to this heat energy supplied over here, the remaining water also will be in a highly pressurized state. So we need to bring down the pressure. We need to reduce the pressure in order for the cycle to again work in a cyclic fashion. So what is happening to the ammonia vapor getting separated at this generator? This ammonia vapor, or this especially this high pressure ammonia vapor, it will be admitted to the normal condenser. So here we are discussing a condenser which has a similar working as that of the condensers discussed in our module 2, that is in our VCRS. Okay, there is no change in condenser or evaporator or expansion valve compared to VCRS. The only change is happening here with respect to the main compressor working. Okay, and the high pressure ammonia vapor so formed, it will be admitted to the condenser, where it will be rejecting the heat, high heat which it has absorbed from this evaporator towards a cooling water circuit. This cooling water circuit will remove the heat content of this high pressure ammonia vapor, turning it into a ammonia liquid. So here ammonia vapor is getting condensed at this condenser to form ammonia liquid, but still this ammonia liquid is at a very high pressure state. So that high pressure will be getting reduced by means of expansion valve in the next stage, and after passing through this expansion valve, this low pressure ammonia liquid will be again admitted to the evaporator or our freezer compartment, where this low pressure liquid ammonia will be absorbing the necessary refrigerating load or the necessary refrigerating heat from the various refrigeration loads which are kept in this freezer compartment or the evaporator. Okay, then again after absorbing heat from this evaporator, this low pressure liquid ammonia will be getting transformed to low pressure ammonia vapor, and this low pressure ammonia vapor will be admitted to the evaporator, where it will be condensing to get dissolved inside water, which will be pumped to the generator by means of the solution pump. At this generator, what is happening? External heat energy is supplied by means of a steam or electrical power supply, and due to this high heat energy, water will be getting separated from ammonia. This ammonia vapor getting formed will be admitted to the condenser and expansion valve like that, and whatever water is remaining inside this generator, that will be admitted back to the absorber. So here we have in a way or we are running the same refrigeration system by avoiding the working of a compressor. So here the working of a compressor is substituted by the combined working of absorber, solution pump, and the generator. Okay, so this is the main idea or working of vapor absorption refrigeration system. So here the term comes in this picture, that is, at this absorber the vapor form of this ammonia is getting absorbed onto a solution containing water. So that is why this term system is having this term, vapor absorption refrigeration system. So here we have discussed a simple type of such vapor absorption refrigeration system here. Okay, so all of you learn this diagram. You have to draw this diagram when you are writing the explanation. So thank you.